Welcome to the notes on Pythagorean theorem and special right triangle applications. Today I'm just going to kind of take you through and see the types of problems that you're going to see on the homework. So let's get right to it. So the first one says to support a sagging gate, you need to run a wire diagonally, all right, across it. If the gate is 5 feet tall, so let's label that 5 feet tall, all right, by 4 feet wide. So I'm going to kind of, this is four foot width. All right, how long must this metal wire be? Remember, we want to attach something diagonally. So you can see that this is a Pythags, all right, Pythagorean theorem problem. All right, so when you do that, remember our formula. It's leg squared plus leg squared equals hypotenuse squared. So you should know what those parts are. So when I look at this problem, we want to find the hypotenuse. So one leg is 4 squared plus 5 squared equals Rx squared. Again, 4 and 5, these are the legs, right? They make the 90-degree angle. So when I do that, 4 squared is 16, plus 5 squared is 25, equals x squared. So this becomes 41 equals x squared. Take the square root of each side. So x equals, you can keep it a square root of 41 if you want, or if you want to make a decimal, it's approximately 6.4. All right, in this case, it's feet that we're talking about in this problem. All right, so there's Pythagorean theorem. Next one, let's take a look. A builder designs a roof with a pitch of 30 degrees. So we're probably talking 30, 60, 90 here, from the gutter to the peak of the roof. So there's our angle there. If the length from the peak of the gutter, from the peak to the gutter is 35 feet, so this distance right here is 35 feet, then how high is the peak? So you can see we've just created a 30, 60, 90 right triangle. We want to find the height of the peak. Let's call that x. So remember, let's compare it to our standard 30, 60, 90. Or this is my 30, so this side's 1. The hypotenuse is double. This is root 3. So to find the height, we're just going to set up a proportion. So we're going to say x is to 1. So I'm going to set that up. X is to 1 as, well, we know that 35 is to 2 equals 35 over 2. How do you solve it in proportion? Cross multiply. So when we do that, we get 2x equals 35, divide by 2, x equals 17.5. In this case, that is feet. So there you have a 30, 60, 90 problem. Let's take a look at one more. Now, it says a radio tower needs to have 3 support wires. So that's going to be big for this problem. Attached to keep it stable. Right now, you can only see 2 of the wires. It's kind of a side view. If the wires need to be attached at 45-degree angles with the ground and attached to the pole 15 feet above the ground, so this height right here is going to be 15, all right? Then how much wires need to support the pole? Remember, there are 3 wires. So this is a 45, 45, 90 triangle problem. So let's compare it to our standard 45, 45, 90, where this is 1, 1, root 2. Now, we want to figure out how long this distance is, but remember, we need to times it by 3 times because there's 3 wires. So let's first find what x is. Well, when I look at my 30, 60, or my 45, 45, 90, x goes with root 2. So x is to root 2. All right, 15 is to 1. So equals 15 over 1 because it's attached 15 feet above the ground. That's the height. We cross multiply, so we get x equals 1x equals 15 root 2. Now that's the length of feet for 1 wire. We need to times that by 3, 1 for each wire, again, because there are 3 wires. So that's kind of the trick to this problem. Coming up with 15 root 2 is pretty easy, but then multiply by 3. So when you do that, the total x is going to equal 15 times 3 is 45 root 2. And you can keep it like that, or if you want, that comes out to approximately 63.6 feet of wire. So that would be your answer. So there you have the 3 types of problems that you're going to see with the applications of special right triangles.